Hello, today we're going to talk about mass percent composition. And before we start applying this to chemicals or to compounds in chemistry, I want to just review what a percent is. So remember that a percentage is always going to be the part you're interested in divided by the total, right? So here I've shown the one piece of pizza you've eaten relative to the total amount of pizza, and it's always then going to be times 100 because percent means per 100. And so that's how we'll get it into the amount. If there had been 100 pieces of pizza, how much would you have eaten? All right, so let's do an example with this just to get us started. Just looking at pizza. All right, so if we have a pizza that has 8 slices and we eat 3 pieces, all right, or you eat 3 pieces, what percentage of the pizza did you eat? So every time you calculate a percent, and we'll do this multiple times in this class, and you probably have done it in other science classes, the equation for calculating a percent is the part that you're talking about. In this case, our 3 pieces is the part that we ate, divided by the total. That would be the whole pizza, not just what's left, the whole pizza before any was consumed, times 100. All right, so in this case, that's going to be 3 divided by 8 times 100, which would be 37.5%. All right, so now let's move on beyond pizza. Let's take a look at an actual chemical that we want to know the mass percent for. So what is the mass percent of nitrogen in N2O? All right, and the problem tells us that we have 7.64 grams of nitrogen in a sample that has 12 total grams of N2O. All right, so again, we're going to use that part divided by the total times 100. So 7.64 is the part we're interested in. This is the part that is the nitrogen. 12 grams is the total N2O, all right, times 100 would be 63.7% of our compound is nitrogen, all right. The other, if we were to do 100 minus this, that other part is all going to be oxygen, all right, and that's always true. The total of all of the parts added together should be 100% if you did all your math right. Okay, so now, how would that be different, or would it be different, if we did the percent of nitrogen just based on the chemical formula? Okay, so we know that if we had 1 mole of N2O, that we would have 2 times the 14.007 from our periodic table. That's the amount of nitrogen that we would have, all right? And then our total mass would be 2 nitrogens plus 1 oxygen, and the 15.999 is the mass of oxygen from our periodic table. Okay, so if we do just the nitrogen divided by the total molar mass times 100, that's 28.014 grams of nitrogen, 44.013 grams of the total compound times 100 gives us 63.6%. All right, that's pretty much the same. All right, experimental data is never going to be exactly perfect, or rarely going to be exactly perfect. So we could say there are now 2 different ways we could get our mass percent for nitrogen. We could be given experimental data, like we are up here, or we could be given the formula and then use that formula to get the mass percent. All right. So in this case, I gave you the formula up here, but you could also be asked, if a compound has a total mass of 12 grams and the nitrogen in the compound is 7.64, then what would be the mass percent? All right, and in the next lesson, we'll figure out how to take that number and convert it into an empirical formula if I hadn't given you one.